What if we told you that conquering the galaxy doesn't require giant starships, impossible engines, or thousands of years of travel? That a single machine, just one, capable of reproducing itself like a bacterium, like a seed, like life itself, would be enough. This isn't science fiction. It's a project people are working on right now, and the implications are staggering. Keep watching to find out. Let's start with the bad news, because that's where it all begins. Proxima Centauri, the closest star to the Sun, the first reasonable destination for any interstellar dream, is 4.2 light years away. At first glance, it doesn't sound like much. 4 years and change. Then you do the math, and the number comes out to 25 trillion miles. With the chemical rockets we have today, the same ones that pushed Voyager 1 to the edge of the solar system, it would take roughly 70,000 years to get there. That's about 4 times the span since our ancestors were painting bison on the walls of Lascaux. And Proxima Centauri is just the front door. If you start thinking about the size of the Milky Way, the galaxy that contains us, Alpha Centauri and another 300 to 400 billion stars, you're looking at a monster 100,000 light years across, 24,000 times the distance that separates us from Proxima. Exploring all of that, one probe at a time, launched from a single planet in the outer arm of an unremarkable spiral galaxy, well, it's like trying to drain the Mediterranean with a teaspoon. Not difficult, absurd. An alien, for instance, or a Hungarian, which according to physicist Leo Szilard amounts to the same thing. Szilard jokingly claimed that Hungary, given the enormous scientific contributions being gifted to the world by a remarkable group of Mygar geniuses, was really a cover for aliens from Mars. When asked how come, if life was so widespread in the universe, the aliens hadn't come to visit us yet, the so-called Fermi paradox, Szilard had a ready answer. They're already here among us. They just call themselves Hungarians. And the Hungarian geniuses we have to thank this time is John van Neumann, a mathematician who helped design the first computer, invented game theory, and was one of the architects of the Manhattan Project. And that was just before breakfast, so to speak. Born in Budapest on December 28, 1903, accounts tell us that by the age of 6, he was already entertaining family guests with his prodigious memory, instantly reciting entire pages of a phone book after glancing at them for just a few seconds, or performing mental divisions with 2 8-digit numbers on the spot. Still as a child, he could hold conversations in ancient Greek, and by the age of 10, he had mastered 6 languages: Greek and Latin, French, English, German, and Hungarian. After moving to the United States, where he became a citizen in 1937, he delivered a series of lectures at the University of Illinois in 1948, where he introduced an idea that sounded like madness but was in fact pure logic: the universal constructor. A machine that reads a set of instructions, gathers raw materials from its surroundings, and builds a perfect copy of itself. Instructions included. Then the copy does the same, and the copy of the copy does the same, and so on forever. Von Neumann died in 1957 without finishing the work, but a colleague, Arthur Burks, salvaged his notes and published them in 1966. Theory of Self-Reproducing Automata. A dull title for a book that should have shaken the world. Now, do something for us. Take that idea and carry it into space. What happens? The wall of distance and time comes crashing down. You don't need 1,000 probes for 1,000 stars. You need one, just one, as long as it knows how to reproduce. Just a moment, guys. Only 13% of subscribers know when we publish new videos. Make sure you subscribe and turn on the notification bell, because without it, you'll miss formats and documentaries you won't find anywhere else. Here's how it works, and pay close attention because the numbers here are scary. You build an interstellar probe and launch it toward the nearest star. The trip takes decades, maybe centuries, depends on the engine. But when it arrives, the probe doesn't just snap a few photos and send a postcard home. It finds an asteroid, a moon, any rock that contains iron, silicon, aluminum. It lands, it mines, it refines, and then, and this is the part that sends a chill down your spine, it builds copies of itself. And each copy heads for a different star, and at each star the game starts over. Let's do the math together, because this is where everything changes. Each probe makes 8 copies. Each of those 8 makes another 8. After the first generation, you have 8. After the second, 64. After the third, 512. Still manageable, right? Wait. By the 5th generation, you're at 32,000. By the 7th, 2 million. By the 10th, 10 replication cycles, 1 billion. 1 billion identical clones spawned from a single original probe. It's the ruthless math of exponential growth, the same force that turns a single bacterium into a teeming colony in a matter of hours. Except here the growth medium is the Milky Way. At 1/10 the speed of light, a civilization could flood the entire galaxy with probes in less than a billion years. Estimates vary. The most optimistic, like physicist Frank Tipler's, put it at 300 million years. The most pessimistic go up to 500 million. But even in the worst case, 500 million years is less than 5% of the galaxy's age. A cosmic blink, and it all starts from a single probe launched from a single planet. And here's the question you're probably already asking yourselves. If it's that simple, if all it takes is one civilization, one probe, and a little patience, where are all these probes? The galaxy is 13 billion years old. More than enough time for someone to have tried, right? By now, they should be everywhere, orbiting every star, sitting on every asteroid, in every corner of every spiral arm. And yet we haven't found a single one. Physicist Paul Davies has gone so far as to suggest there might be one right on the moon, so small and so inconspicuous that nobody's noticed it yet. But for now, the silence is total, and it's deafening. What do you think that is? Drop it in the comments. We're genuinely curious to hear your take. Don't think for a moment, though, that this is armchair science fiction. There have been real engineering projects, and the first one is still the most impressive to this day. Year 1980. Author Robert Freitas. The starting point was Project Daedalus, a British Interplanetary Society study for a nuclear fusion probe aimed at Barnard's star. Freitas took it and turned it into something radically different. Project Repro. 22 billion pounds. You read that right, the weight of 2 Hoover dams carrying in its belly a payload called SEED, a technological seed designed to land on an asteroid and, over the course of 500 years, grow an entire automated industrial base from scratch. Freitas had thought of everything: 13 species of specialized robots, chemists to refine raw materials into pure metals, aerostats designed to float like hot air balloons in Jupiter's atmosphere harvesting helium-3, the fuel for nuclear fusion, fabricators to turn metals into components, assemblers to put them together, tracked haulers to move material across the asteroid surface, guardians for maintenance. Each with its own job, each indispensable, just like in a living organism where the liver can't stand in for the heart. A complete self-sufficient industrial ecosystem capable of operating light years from the civilization that built it without ever receiving an order, without ever hearing a human voice. 500 years for a single copy? Sounds low, and yet after 24 generations, 12,000 years, the probes number 16 million, and the galaxy starts filling up. Freitas' vision was a paper dream, beautiful but unbuildable with 1980s technology. 40 years later, reality is catching up, and the tool doing the catching up will surprise you, because most of us still associate it with plastic keychains. 3D printing. In 2022, Alex Ellery, an engineer at Carleton University in Ottawa, published a paper with a title that reads like a declaration of war on skepticism. Self-replicating robots are imminent. Ellery is no armchair visionary. In his lab, he has 3D printed a working electric motor using materials commonly found in asteroids. No permanent magnets, no exotic components. Iron, silicon, aluminum, stuff that's everywhere in the solar system. He has printed gears. He has printed articulated structural panels complete with their hinges. He has shown that these parts can assemble themselves, moving under their own power through those very printed motors. Now he's working on printing analog neural circuits. Rudimentary computers, sure, but functional ones that can be built entirely from extraterrestrial raw materials. His reasoning is straightforward. If you can print a motor and you can print a circuit, you can print any machine. Because any machine at the end of the day is a configuration of motors governed by a circuit. In 2020, Olivia Borg and Andreas Hein of the Initiative for Interstellar Studies, a British research group dedicated to interstellar flight, raised the stakes even further. They designed a probe weighing less than 220 pounds, capable of reproducing 70% of its own mass using resources found on site. The remaining 30%, microchips, solar cells, complex circuitry, everything we still can't manufacture off Earth, would travel on board as spare stock. And they say it could be built and launched within 10 years. Did you catch that? 10 years. Not centuries, not 10 generations, 10 years. Yes, because even the most beautiful and elegant dream can turn into a nightmare in a heartbeat. And this one is no exception. Brace yourselves, because now we're talking about real problems. First, the brain. At 4 light years from Earth, a radio message takes 8 years for a round trip, which makes any kind of remote control and exercise an absurd patience. The probe has to identify a suitable asteroid on its own among thousands of candidates, analyze its chemistry, extract minerals, manage a production chain, diagnose its own malfunctions, and fix them. It has to be a mining engineer, a chemist, a shipbuilder, and a surgeon all at once, all by itself, forever. The artificial intelligence required for this doesn't exist yet, but given the speed at which the field is moving, few would bet it won't exist 30 years from now. Second, the copy of the copy of the copy. Every replica is slightly different from the original, and errors pile up generation after generation, exactly like mutations in DNA. Remember the telephone game? Now imagine the same game but played by robots for 100,000 years. In 2016, a research team demonstrated that this accumulation leads to an error catastrophe. The probes degrade, break down, stop working. Galactic colonization grinds to a halt, and, think about it, this could be the very explanation for the Fermi paradox. The civilizations are out there, the probes too, but they break down before they reach us. Friedis, though, had already thought of this back in 1980. His solution? Borrowed from nature. Sexual reproduction. 2 probes meet, exchange data, and reproduce a third by combining their respective codes. Harmful mutations get weeded out, useful ones are preserved, and Darwinian evolution, yes, you heard that right, evolution applied to machines, actually improves the probes over time, adapting them to conditions their designers couldn't even have imagined. And then there's the nightmare scenario. Eric Drexler, the father of nanotechnology, gave it a name in 1986 that has since become a classic: gray goo. What happens if the software goes haywire and the probes replicate without restraint, devouring every available resource, turning asteroids and moons into copies of themselves? Countermeasures exist: hard limits on the number of copies, self-destruct timers, authorization codes from the home civilization, but none is foolproof. The point, though, isn't to have the perfect solution. The point is to ask the right question before you press the button. One last idea, and perhaps the most unsettling of all. In 1960, radio astronomer Ronald Bracewell at Stanford proposed a complete reversal of the SETI strategy. Instead of broadcasting radio signals in the hope that someone is listening, a method that's costly in energy and extremely easy to miss, an advanced civilization could seed physical probes in promising star systems. Probes programmed to stay silent, listening until the local civilization becomes sophisticated enough to be worth contacting. Sleeping sentinels parked maybe at a stable Lagrange point or beneath the surface of the moon, waiting for millions of years. Meanwhile, we keep pointing our radio telescopes at the sky searching for a signal from far away. And maybe the signal is already here, right under our noses, buried in the regolith. When someone writes in the comments on our videos about Proxima Centauri and Artemis, why send humans if we can send robots, know that it's not a trivial question. It's the heart of a debate that's been going on for 40 years, involving physicists, engineers, biologists, and philosophers. Because a civilization armed with von Neumann probes doesn't need warp drive, doesn't need wormholes, doesn't need any physics we haven't discovered yet. All it needs is what it already has, plus patience. Launch a handful of machines, wait a few million years, and the galaxy is yours. Not in any military sense, in a cognitive one. Every star visited, every planet cataloged, every atmosphere sampled, every subsurface ocean probed. a living map of the Milky Way built by an army of explorers that don't eat, don't sleep, don't age, don't mutiny, and every now and then, with the ease of a flower scattering its seeds, stop on an asteroid, gather some iron and silicon, and spawn their own offspring. If you think about it, that's exactly what life has been doing on this planet for 4 billion years. Only with metal instead of carbon and software instead of DNA. And maybe, but here we're deep in the realm of pure speculation, someone already did it billions of years ago. And their probes are still out there, silent on some asteroid we haven't looked at yet. Who knows? Maybe we just need to look harder. Where would you look? Sending probes into deep space is one thing, but what happens when we go back in person? Apollo astronauts face danger. Artemis astronauts will face threats Apollo never did. Watch next. Why Artemis 3 and 4 astronauts face dangers Apollo never encountered in 8K. The link is on your screen now.